Good afternoon, everybody. My name is Andrew Goodwillie with the AIDA group at Lamont Doherty Earth Observatory, and welcome to the first of 4 GeoMapApp webinars. I'm here with my colleague Leslie Shee, also in the AIDA group, and Leslie is kindly going to monitor questions if any come in. And we'll wait just a minute for a few other people to sign on. We have a few more people registered. So let's just wait a couple of seconds. And whilst we're waiting, I'm going to ask if people can hear me. So Suzanne in Finger Lakes and Lisa over in OMO, if you can hear me, can you type in your question box that yes, you can hear the webinar? Okay, sounds like we can be heard. So you'll notice in the GoToMeeting panel there's a questions box, and as we go through this, if you have any questions, please type them in there, and Leslie will monitor them and pass them along to me, and we'll try our best to answer them in real time. I should also say that this webinar is being recorded, and we'll place it on YouTube hopefully next week. So if you don't quite catch everything, no problem, you can just look it up on YouTube. Okay, so let's begin. Let me get rid of my introduction slide. Cancel that. Okay. So I'm assuming everybody has downloaded and installed GeoMapApp, and so you have a GeoMapApp icon somewhere on your computer. So let's start it by double-clicking. When the window comes up, the first thing we see is that there are 3 possible projections we can choose from. There's the Mercator projection, that's the default. In the middle we have the South Polar, and on the right we have the North Polar. For this webinar, this introductory webinar, we're going to look at the Mercator projection on the left. And we can check it's highlighted by looking at the blue box around the edge of it. So we'll hit Agree to open GeoMapApp, and the program starts to open. Okay, so here we have the GeoMapApp window. And you can follow along as much as you can. There'll be some places where I may go a little bit fast or slow. And if anything gets ahead of you, you can just watch the webinar at a later time to catch up. And I should also say that we have short tutorials, short webinars on YouTube for every function and every aspect of GeoMapApp that I'll demonstrate today. So GeoMapApp is a data discovery and exploration tool and visualization tool, and today we'll have a look at some of the basic functionality. So when the window opened, we see 3 main areas. There's the map window here with a base map. We'll talk about that in a second. Up at the top, we see a row of menu buttons, and if we click on one of these menus, we see various items in it. Beneath the menus, we have a row of toolbar buttons. This is the toolbar with each of these icons being listed when we hover the mouse over the icon. So, for example, this one here says Distance Profile Tool, and over here we have the zoom buttons. And when I move the cursor in the map window, we see just above the map that the latitude and longitude of the position of the cursor is listed. On the left, we have longitude and latitude listed as degrees and minutes, and on the right, the pair of numbers there is longitude and latitude listed as decimal degrees. So let's have a look at the structure of the map window of the map. This is a base map that we call the Global Multi-Resolution Topography Synthesis. It's a GMRT. It's one of the AIDA products. And it's made from a number of different data sources. It's a global digital elevation model. On the land, we have the 30-meter NASA Japanese Space Shuttle data set, the Space Shuttle Radar Topographic Mission data. On the lower 48 states, Hawaii and Puerto Rico, we have the 10-meter resolution USGS National Elevation data set data. And in the oceans, we have a mixture of cleaned, processed multi-beam swath data and grids that were contributed to the project by a wide range of researchers and contributors, as well as the predicted bathymetry of Smith and Samwell. So let's take a look at this elevation model in a bit more detail, and we can do that by going up to the toolbar and clicking on the Zoom In button, which is the plus sign here. And we can choose anywhere on the map. Let's choose, say, the East Pacific Rise down here, for example. And as I click in, the map automatically zooms. I could also draw a rectangle around the area to which I want to zoom, and the map will zoom to that area. So 2 ways to zoom in, clicking with the mouse or drawing a rectangular box. So here we see that some parts of the East Pacific Rise have lots of detail and other parts look a bit fuzzy. And we can look at that detail by clicking on the map, the mask function, which is this one here, the third from the right. And when we do that, we see some transparent areas and some gray areas. The transparent areas are places where we've used high-resolution multi-beam swath data, and in some places high-resolution contributed grids of, in this case, bathymetry, ocean depth. And the gray areas are where we use the background lower resolution predicted bathymetry that's derived from satellite altimetry data as well as shipboard soundings, the Smith-Samwell dataset. If we want to look at the specific source of data, down in the bottom there's an information button, and when we click that, then a window appears and it lists all of the different data sets that are used in this particular part of the base map. So it's telling us we have the Smith-Samwell dataset, and if there's any land in there, we have the SRTM Aster land dataset. For cruises, we have a whole list of cruises here that have been cleaned and added as multi-beam swath data to help make a detailed grid. I'll close that. Okay, so that's a quick run through of the structure of the base map. I'm going to untick the mask function, so we're back to the regular base map. And I want to zoom back to the world scale, the global scale, and there's a shortcut to do that. We could click on the zoom out button and repeatedly click in the map, or we can go under bookmarks, and there's an item down here called zoom to global scale. And when we click that, then we instantly go back to the world view. So let's take a look at an area around Mount St. Helens, and we'll explore in detail some of the elevation data sets and how we can manipulate the gridded data that's used to make this base map. So I check that I'm still on the zoom in button, and I'm going to look in the Pacific Northwest area here. So I'll draw a box to zoom in on that area, and it's fuzzy. The program is going to the server to pull in the tiles, and then we start zooming a bit more towards Mount St. Helens. So here we see the Pacific Northwest. We have Mount Rainier in the middle there, Mount Adams, and Mount Hood, and over here on the west is Mount St. Helens. So I'm going to zoom in a bit more on that area a couple of times, and we see the higher resolution tiles have been pulled in, and here we have a detailed map of Mount St. Helens. Now at this point we're only looking at a set of pre-made images. It turns out it's a lot faster to serve JPEG images over the internet than it is to serve the underlying data from which the images were created. But this relies upon a color palette that we chose and some shading that we chose, so it may not be optimal for what we need. What we're going to do then is make some changes to this base map by loading the underlying three-dimensional data set. So we're going to load in the X, Y, and Z values so we can do a lot more stuff. So one of the things we might want to do is generate a profile, a topographic profile across this region. So let's have a go at doing that. First off, I'm going to deactivate the zoom button, and then a couple of icons over, if I let the mouse linger, I see that there's the distance profile tool, and I click once on that. So a few windows opened, and there's a processing window. The colors in the map changed. I see a layer manager window. We don't need that just yet, so I'm going to minimize that. And there's also a global grids window that may be parked down in the bottom of the screen, or it may be visible. I'm just going to park it again. Okay, so we're taking a profile. So the mouse can be used to draw the profile line on the map. So I draw a line by dragging the mouse across the map, and there's the profile window. It comes up pretty instantly. And as the cursor is moved in the map window, we see on the profile line on the map that there's a small red dot and a circle or a square to show us where the cursor is located. Also, notice that in the profile window, we have the longitude and latitude of the cursor, as well as the elevation value, the gridded third dimension value at that particular point. So as the cursor is moved, those numbers change. And we can draw another profile if we wish, say over here, and one over here, as many profiles as we want, and it just replaces the existing profile window. Okay, so if we want to save that profile window, we can go to the Save button, and there's a number of options to save it. We can save it as an image or as a table, and send it to the printer, or put it in a report, for example. So for now, I'm going to eliminate the profile window, and let's explore some of the features of the global grids window that appeared. So this is like the grid control window. I'll just move the map window up a bit more. Okay. So here we see a number of different components within the window. So one of the first ones we can play with is the artificial illumination. So over on the right here is a little target symbol, and the yellow indicates the position of the artificial illumination, currently coming from the northwest. Let's drag it down to, say, the southeast. And when we drag it and let go with the cursor, then the illumination changes and we see the effect on the map. If we make it come from the west, we can do that. And we can put it back to wherever we prefer. Okay. So as I mentioned before, when we're looking at the profile window, when we move the cursor in the map window, we see just at the top bar, we see the third dimension value is displayed. So that can be a very quick way to find the value of the gridded data set and the location of the cursor. So another part of the control window for grids is this color area in the middle. This is a histogram showing the distribution of colors for this gridded data set. And there are these two thin gray lines, one over on the left and one over on the right. By dragging these lines to the side, we can change the color palette, the color scheme, very easily. So let's drag this line that way, and this other line over here, so we can see how the color palette is changing. It's taking just a couple of seconds to do this operation. I should also point out there's a palettes menu, and clicking on the palettes menu brings up a list of palettes from which we can choose. There's the default one, that's the one, or the land one is the one that's listed here. The default one is used for the whole world. There are black and white options, rainbow ones, and the user can create their own palette and even save the palette that's on display. So we'll stick with the one that we're using here. We can put contours on this map if we wish. There's a contour button right here. We click once on that, and a window pops up, and it gives some suggested values. There's a contour interval of 100 meters, starting at 400 meters and going up to 2600 meters. And we can change any of these numbers, or we can accept the default values. So let's just accept those. And there we see the contours quickly drawn on top of the map there. We deactivate the contours by clicking once more on that button. We can change the vertical exaggeration, which makes the contrast of the shadows more prominent in this box here, the VE box. So let's change it, say, to 3. And now we see the shadows became more pronounced. And we already looked at the profiling tool, and there's another way to get to the profiling tool by clicking the button here. I can draw the profile like so. And let's say that we have this map and we want to keep it for a location map. So we can save it if we go to the File menu, and down towards the bottom there's a Save Map Window option. And when we click that, we get a number of choices. We can save the gridded data in various formats, and in the lower half of the options we see 4 different options for saving the image. And the default is a JPEG, but if you need a map for publications, say, you may wish to choose the PNG option that has a slightly better resolution. Okay. So, are there any questions at this point? All right. If not, let's eliminate the grid that we've been exploring. So I'm going to go back to the global grid window, and I'll hit the... Oh, before I close it, I'll just show quickly the 3-dimensional way to look at this gridded data set too. We can flip between 2D and 3D, and when we're in 3D mode, then we can quickly make a 3-dimensional perspective plot of this area. So here we are rotating Mount St. Helens. So let's say we want to keep it like that. We can use the controls here, and these are all described in the short tutorials that are on the GeoMapApp YouTube channel. And once we're happy with the view, we hit render as an image, and there's a quick way to get a 3D perspective view of that area. Okay, so I'll switch back to the 2D, and we're going to move on. So I'm going to close the grid, eliminate the grid by hitting the close button here. So we see that the colors in the map reverted to the pre-made colors, and now we're looking once again at the images that we made for the whole world for this digital elevation model. And I'll go back to the world scale by going to bookmarks, zoom to global scale. There we are. So some of you may have downloaded the files that I sent in a message a few days ago. And if so, and you wish to follow along at this point, I invite you to find the grid file that you downloaded, and I'll go and find mine. It's over here. I put it under here. So we're going to look at some of the import functions, and GeoMapApp allows us to import a range of data sets in different formats. If we look at the File menu, we can import as a web feature service or web mapping service, and then we have other ones that allow us to import a gridded data set, a shapefile, and a spreadsheet. And it's these three, the grid, shapefile, and spreadsheet, that we'll concentrate upon in this webinar. So let me just go back to the window where I have the grid. So here's the gridded file, and it's a file that was contributed by Syracuse and Abers, and it gives us the depth to the top of the subducting slab, in this case for the Andes subduction zone at the Peru-Chile Trench. And the format of this grid is a NetCDF format, You can think of those like .grd files that are produced, say, from the GMT software or from NV system. So a netCDF grid. So I go into the File menu and down to the Import 2D Grid File option. And pulling over to the right, I'm going to import this file from the local file system. And when I select that, a window pops up asking me to choose the format. We see various formats we can import, an Esri, ASCII, Esri binary format, and a couple of others, but we'll accept the netCDF format, and we'll hit OK. And now I have a navigation window. I need to go and find that file. So if you navigate to where the file was stored, and here's the place where I stored mine. And once I find it, I select it and hit Open. So at this point, the GeoMapApp application has located the grid file, and it's read the header that's associated with that grid. The header values are listed in this window here. So it's giving us the boundary of the grid, so the west, east, south, north values. Here's the west, east, south, and north. And then in terms of the third dimension, we have the minimum and maximum Z values, and here we see that they're 50 to 299, and I just happen to know that the units here are kilometers. And because I want to impose the depth of the slab being increasingly negative downwards, then I need to apply a factor, a scale factor to this grid of -1, and that will convert all the values in the grid to be their negative equivalents, and that will help us make sense of it when we view the grid on the map. And I can do that scaling by going up into the middle of this window, and I see there's an area where I can change the scale. So I put -1 in there, and then hit the OK button. So things happen very quickly there. I should explain what did happen. Well, we see that the grid has been loaded, and we'll look in detail in that in a second. But let me just go to the folder where the grid resides. And there's the file that we imported, and we see that a bunch of other files and folders was also created. And this allows us to zoom in on the map and still see detail as we continually zoom in or out. It also creates a shapefile, and that can be imported to other programs. So let's have a look at the grid that was imported. If we click the zoom button, zoom in up here in the toolbar, then we can click or draw a rectangle on a particular area. So let's say zoom to this area. And we see that the imported grid, the grid that shows the depth to the top of the subducting slab, has been overlain upon the base map. So one thing we can do with this grid, like we did before, is we can draw contours on it. And for that, we need to find this window that looks like the one we were playing with before, the contributed grids window. So it has a very similar structure. There's the artificial shading area, the distribution of colors in the color palette, and here's the contour button. So let's put contours on this grid. The suggestion is 10-kilometer contour starting at 150 kilometers depth, coming up to 50 kilometers depth. So okay, let's accept those values. We hit OK, and there we see the contours on the top of the subducting slab. And before I forget, I'm going to deactivate the zoom tool so that if I click on the map I don't mess myself up. Okay. So let's also have a look at taking a profile across this grid. So back in this window I see the profile button, and that's what I'm going to use. Now I should say at this point, when we took the profile across Mount St. Helens, we clicked the toolbar icon up here. That is actually a shortcut, and it loads the digital elevation model and allows us to generate profiles of elevation or ocean depth. But now that I'm looking at a separate data set, a different type of data, I need to activate the profile function from the grid control window down here. So we click once there and draw the profile line, and there we have a profile of the subducting slab in this part of the Andes. And just like before, we see the numbers that change at the top of the profile window, as well as here in the top of the map window when the cursor overlies the grid. I need to point out that the default units in GeoMapApp for imported data sets is meters, but in this case the grid was in kilometers, so we just have to keep that in mind. Okay, so there's the profile, and I'll just move that profile window out of the way. Well, what happens if we want to compare this imported grid with the base map, for example? Do we have a transparency function? Yes, we have. And I can activate that transparency function by finding the layer manager window. Now, if we can't remember where it went, we can just click the rightmost icon in the toolbar, and it'll bring it right back up. So here, I can plot or unplot the grid, like so, by ticking the box there or unticking the box. We can also change the opacity and make the grid transparent by sliding this slider bar sideways. So there we've made it completely transparent, and now we're bringing it back like so. So this offers a very quick and easy way to compare data sets in a geospatial setting. Okay. So what happens if we want to import another grid for this area and we have it in the same folder? We noticed before that a bunch of files and folders was created when we imported the grid. If we wish to import a second grid, then we would need to do it in a separate folder because these files will get overwritten. It is possible, though, to import multiple grids at once, and for that we would navigate to the place to one folder that contains all of the grids and just select all the grids, and they're read in all in one go. Alright, are there any questions on importing grids? No, Leslie's telling me there are no questions, so we'll move on. Okay. I should say that this webinar, we're aiming to have it to be 45 minutes in length, maybe a little bit shorter, so we'll see. So I'm going to close various windows here. Let me just minimize that. I'm going to first eliminate the grid so I can hit the close there. And I don't need this window up here. And I don't need the layer manager window. And I'll go back to the world view by choosing bookmarks, zoom to global scale. Okay. So let's now have a look at importing a shapefile. And for this, I'll show you where I stored the shapefile. I need to go up, and here's my folder. And this is a shapefile that was in the link of the downloaded file of files to download that I emailed a few days ago. It's a shapefile that delineates the outline of a 2005 to 2006 lava flow, and it was donated to us by Adam Sewell at Woods Hole Oceanographic Institution, and it's for the area of the 9 North Ridge 2000 study site, integrated study site on the East Pacific Rise. So in the shapefile folder, I need to have these three components, the .shp file, the .dbf file, and the .shx file. Shapefile components, there are usually more, but we need at least these three. And as long as we have these three, we should be able to import that shapefile. So let me minimize that. And again, we go up to the File menu, and we go down till we find the Import an Esri formatted shapefile option. Okay. And there we pull over to the right, and we want to import this from the local file system. So we select that and we go and use the navigator window to find that shapefile. And there we go. So this is the location that stores the shapefile, and we need to select the .shp file. And once it's selected, we can click Open, and it loaded instantly. It's a very small file. So you may not be able to see on the webinar screen, but I can just see a tiny dot in the middle of the map here. What I'm going to do is find the Layer Manager window, and I see that listed with the shapefile that we just imported, there's a zoom button. By clicking this, it's a shortcut that will zoom us right in to the area of that shapefile. So let's click this once. There we go. Now I can minimize that Layer Manager window. Okay, so this is the extent of the shapefile. I'm just going to scroll the map a little bit. There's a bit down the bottom there. Okay. So there is a question, what is a shapefile? A shapefile is a format, a very commonly used format for GIS, Geographical Information Systems, for looking at geospatially registered data. And if you do a Google search for a shapefile, it'll give you more information, and you can find a plethora of shapefiles, free shapefiles available on the web. For example, population data, cities, outlines of lava flows in this case, a whole bevy of data sets available. Okay, so here's the shapefile. And in the Shapefile Manager window, by clicking on the name of the shapefile, then I see that in this case, this shapefile has 4 separate components. We can click through like this and look at the different ones, and every shapefile is going to be different. So in this case, it's just showing the 4 different areas that were outlined for these lava flows. And we see that the area around the shapefile is fairly fuzzy. We're zoomed so far into the East Pacific Rise that we're going beyond the resolution, the native resolution of the global multi-resolution topographic synthesis dataset, the base map. However, one thing we can do is, for this particular area, we do have a number of built-in datasets that are very high resolution. And we can load one of those now, and then we'll show how the layering takes place. So let's see. Oh, there was a question, how do you open the Shapefile Manager? It will usually have opened automatically, but if not, there's a shortcut to it in the toolbar here. It's the 5th or 6th one along, the one that looks like a polygon. And if you click once on that, it should open the Shapefile Manager. So thank you for that question. Okay, so let's load in a high-resolution data set, and then we'll show how we can layer different data sets. So for this, I'm going to go to the Base Maps menu, and that's the second menu along. And we'll go into, before I go into there, I'm going to click on the top item, the searchable tear-off menus. What that does is it creates a new window, and it makes it a bit easier to navigate the menus, especially if there's lots of cascading menus. So let's click once on this top item, and now we have this independent window, and it makes it far easier to find what we're after. So we'll go into the Regional Grids item, which is the 3rd item down, choose Bathymetry, and we go down to Pacific Ocean. And somewhere in here, there we are, East Pacific Rise, 9 North, and then let's see what options we have. Okay, so it's this top item, this high-resolution gridded dataset, the 5-meter horizontal resolution, it's very high-res, that was gathered from Abe, the vehicle that goes underwater close to the seafloor. So we click once on this and hit the OK button. So just like when we have loaded a gridded data set, I'm just going to minimize that, we again see the grid control panel, and we see that a small area of the grid appeared here. So let's zoom into this area. We can click once on the zoom button, and we'll zoom in. We can go a little bit further and say a bit more. Okay. And we see GeoMapApp going to the server and pulling in the higher resolution information. So here we see this tremendously detailed map of the East Pacific Rise 9 North site at 950 North. And we notice in the background we still have the outline of the lava flow. So if we find the Layer Manager window, I have it parked down here. If I didn't see it there, I could just bring it up from the rightmost icon in the toolbar. And here we see that the lava flow outline is the second item in the list. We can promote this item up to the top by using the arrows over on the right. And by doing that, now we've switched the order of the layers, and we put the lava flow outline on top of the bathymetric grid, which is in turn on top of the base map. Okay. So that's one example of how we can layer different types of data sets in a particular geographical area. And if there are no questions on that, we'll go to the last example of importing data sets, of looking at a tabular data import. So let me get rid of some of these windows. I'll close the Layer Manager, close the Shapefile Manager, and find the grid, get rid of that. And oh, I forgot to shut off the shapefile itself. There we go. Okay. And then I'll go back to the world with the shortcut bookmarks, zoom to global scale. Okay, so for the final example of importing data sets, we'll look at importing a spreadsheet. And for that, let's just go and find the spreadsheet on our local computer. Here it is. Okay, so this is a spreadsheet. I'll open it so we can look at it. And it's actually a downloaded data set from the EarthChem geochemistry portal. We see that we have a top row containing column headers. And if we look at some of these headers, we see that we have a latitude column, a longitude column, and a sample, rock sample ID column. And if we scroll to the right, then we have the geochemical analyses over here. So we can import this spreadsheet into GeoMapApp, should be no problem. So I'm just going to close that and go back to the File button. And we look down for the Import Table or Spreadsheet. And once more, we're going to import it from the local machine, and in this case, it's an Excel formatted file, so it's the 5th item in the list there. And we select that. So now we use the navigation window to go find that spreadsheet. Here it is. So select it, hit open, and a little window appears to tell us it's reading the file. And once it's been read by GeoMapApp, the values are displayed in this intermediate window here. We hit the OK button. So we get a window coming up, a configuration window, and it's just checking with us. It's checking that we can check that the GeoMapApp application correctly identified latitude and longitude. These could have been called something else, in which case we would need to go into the drop-down menus and choose which column is latitude and which is longitude. And that's because we need to know how to plot the points on the map. So everything looks good here, and we'll just hit OK. OK, so 3 things happened at that point when I hit the OK button. We see some symbols, circles, appeared on the map, all right? Then over on the right of the GeoMapApp window, we see a new control panel opened up, and we'll explore some of these functions in just a sec. And down in the lower part, we see the contents of the spreadsheet. So let's zoom to this area. It's geochemical data for the Marianas region. So I'll hit the zoom button and go in like so. Okay. And I'm just going to deactivate the zoom because I will need to later click on the map, and I don't want to zoom anymore. So here we see all of the data points are shown as gray circles. If we click any of these symbols, then the particular record that we've clicked in the map is illuminated in the table below. We can go the other way. We can go in the table and find a record and click it there, and it will light it up in the map window above. So a couple of ways to quickly choose certain data records. Okay. Another thing we can do is if we scroll over to the right here, we see that we have some of the geochemical analyses values. If we click on any of the column headings, we can sort the data. So here I'm sorting the data in reverse and then increasing order. That might be a useful thing that we need to do. And we can now really explore the values that are contained in this spreadsheet by manipulating the symbols. So we see that they're plotted in their geographical context, but now let's go and color the symbols according to the alumina content, say aluminium oxide. So, oh, I should show how I did that. So I went over to the right panel and I clicked on the color button, and this separate window appeared. And if you notice, it contains the column headings from the spreadsheet. So in this window, I go and find the alumina value, the column heading, there it is, Al203, and hit OK. And now we have colored symbols in the map and a window, a color palette window that opened that allows us to change the colors of those symbols. So just like when we were exploring gridded data sets, we see that there are these two thin gray lines, and we can drag these to the sides and change the colors accordingly, just like that. Okay, so let's just move this out of the way for now. Well, we can also scale the symbols, change the size of the symbols according to another value. So let's have a look at that. If we scale, hitting the scale button over here, and let's scale on magnesia, MgO, which is here, and hit OK. And we get a similar histogram window, and by dragging these lines we can change the size of the symbols, like that. And we can also graph any two numerical columns against each other. So in the spreadsheet there's nothing to stop us graphing, say, silica against K2O. So let's do that. And we do that by hitting the graph button over on the right. And we choose what we want for the x-axis. So we'll go and find silica. There it is. And we'll find the y-axis value, which will be K2O in the middle there. And we hit OK. All right. So here we're looking at 4 different parameters for this particular data set. We have the colors of the symbols are colored on alumina. The symbols are scaled in size on magnesia. And then in this window we're graphing the symbols that retain their color and their scaling from the other parameters, and we're graphing silica against K2O. And all the while we're looking at the data set in its correct geospatial setting. So we can quickly explore this graph tool window here. If we want to change the range of the axes, we find the blue boundary around the edge and click once on it to get the double-headed arrow, and we can drag that boundary as we see fit to change the scaling. Let's move this one in as well. And we also have the ability to grab a bunch of data points for further study. So let's turn on a lasso tool, which is this symbol here, and we can use the freehand drawing, and all of the symbols that were captured, all of the data points captured by the lasso there, are now highlighted on the map and highlighted in the table below. And we can save those values, the selected values, by going to the Save button, and there's a Save Selection suite of options down here. we can save those, for example, to Excel and send them to a colleague, for example. Okay, so let's say that we want to save this map window, say we need to write a report on it. If we go to the File, Save Map Window option, then once again we see the choices we have to save the image there as a JPEG, PNG, and a couple of other formats. So in the last minute or two, we're just about out of time. In the last minute or two, we'll look at a couple of the built-in data sets. So for that, I'm going to close the loaded data sets, and I'll revert to the global map view. So I go to Bookmarks, Zoom to Global Scale. And let's take a quick look, say, at earthquake data. There's a whole bunch of data built into GeoMapApp. If we look under the Datasets menu and go to Earthquakes, then we see that there's the NEIC catalog is here. And you can just watch for this if you wish, or you can try and follow along. I'm going to load the earthquake catalog from 1973 to 2013, so a 40-year period of earthquakes. And it's loading the file. There it goes. And GeoMapApp tells me that there's more than 10,000 data points in this data set. And we just acknowledge that. Now, they've all been loaded into the GeoMapApp application, but they've not all been plotted. However, as we zoom into a particular area, all of the values for that region will be displayed. So since we're looking at earthquake data, this is very similar to the geochemical data we were looking at in terms of we have tabular data, points on a map. So we can, say, color the values according to the depth. And just like we did before, we can change the color range. And let's say we want to zoom into the area up here around Japan. So I'll zoom in up there. There we go. And we can scale the symbols according to, well, magnitude's an obvious one for that. So let's change the scale according to magnitude. And if we drag that, then we can see that the bigger symbols are the bigger earthquakes. And again, we have the table down at the bottom that we can sort and select from. And the last couple of items I'll show, so that's looking at earthquake data, one of the built-in data sets. Let's have a quick look, say, at gravity data, which is, we have a global data set for that. So for now, I'll quit the earthquake data set, and I'm going to pan the map. So I'm going to select the panning symbol and go over to Hawaii. And then for the gravity data, we'll go to Base Maps. It's under the Global Grids menu. And I'm going to select the Samuel and Smith gravity dataset. So it's loading from the server. And here we are. If I zoom in a bit more on the Hawaiian region, like that. So here we have gravity overlain on the base map. And if I find the Layer Manager window, we can check the transparency and then compare the gravity free air anomaly values to the bathymetry and land elevations. And because in this case it's a grid that we loaded, we can draw a profile across this data set like that. Oh, that wasn't a very good choice. Let me get a better one. Oh, that's even worse. Hold on a sec. Let me find a good example. There we go. So now we have a classic example of lithospheric flexure on the Hawaiian Emperor Seamount chain. We see the lithosphere bending down in the gravity and the infilling, or the lows caused by the infilling of water instead of rocks and sediments there. Okay, so we're just about out of time, so I'll say that there's so many data sets that are built into GeoMapApp that I invite you to spend some time exploring. In base maps, we've got a range of geological, geophysical data sets. There's All of the US state geology maps are built into GeoMapApp. All kinds of land cover and physical oceanography data sets we have for polar regions. We have ice cover information and glacial data. Under portals, there's a webinar, the fourth one in the series. We'll look in detail at each of the portals, but that's where there's customized interfaces to explore things like multi-channel seismic data, for example, and the earthquake focal mechanisms information. Data sets is where we find earthquake data, links to seafloor photos, volcanoes and seamounts information. Under there we have Smithsonian, the Global Volcanism Program data set, and so on. So if you need help with any of GeoMapApp, there's a help button over in the upper right, the last menu on the list, and there's the way to send comments and suggestions, and there's also a link to multimedia tutorials, and these are the ones I mentioned previously. Let's click that, and you'll see here that it takes us to a web page, and it contains all of the hyperlinks that take the user to YouTube videos. And in this tutorial we covered everything in introduction. We imported most of those data sets. We analyzed tabular gridded data sets. We made profiles. We worked with gridded data. And we looked at a couple of the base maps and data sets. And all of these videos are just a few minutes long, if that. And provide lots of extra information, provide the detailed information. And the final thing for me to say is that when we finish this seminar, I'll send an email that contains a link to a very short SurveyMonkey survey. The survey probably takes about 1 minute, if that, maybe just 30 seconds, and we'd really appreciate your feedback, not only on what you've seen of GeoMapApp, but also on the webinar itself. The survey asks if you could understand the webinar, if you had any difficulty loading GeoMapApp, and that sort of thing. So I'll send that to everybody registered in a few minutes. So thank you very much for your attention, and if you have any questions, please send them along, and we'll do our best to answer them. Thank you. Bye-bye.